In this podcast, we're going to talk about the Kelvin scale of temperature. Now, we've already talked about temperature as a measure of the average kinetic energy of all the molecules in a sample. And we know that the energy, the kinetic energy, really just means that the molecules are moving. Kinetic energy is the energy of motion. Now, we're fixing to talk about why the Kelvin scale is so important. Kelvin is what is commonly used in science, especially when we're talking about gas laws. When we're talking about gas laws, we're talking about movement of the particles. And none of the other temperature scales actually correlate to the pressure scale. Now, when molecules move, they run into one another and they run into their surroundings, their container. These collisions exert force on the molecules. This force is known as pressure, okay? So pressure is force per unit area. So the force is the collision of the molecules, and the area would be the container that they are in. Now, when we're talking about having no kinetic energy, like 0 Kelvin, absolute zero, then we would expect to have 0 pressure. And that's exactly what you see on the Kelvin scale. None of the other scales of temperature have that direct correlation to pressure. So 0 degrees Celsius is not 0 atmospheres. It's not 0 pressure. So they don't correlate like the Kelvin scale does, which is why the Kelvin scale is so important. Now, to get from Kelvin to Celsius, we'll use the equation K equals C plus 273. K is any temperature you have in Kelvin. C is any temperature you have in Celsius. So if you were given something in Celsius, you would put it where the C is, add 273, and that would give you to Kelvin. If you had Kelvin, you would put it where the K is, subtract 273, and that would get you to Celsius. So let's see some examples. So in this one, it says how much is 305 Kelvin in degrees Celsius. So we know that if it is Kelvin, we're going to put it in the K spot. So K equals C plus 273. Okay, and then we would subtract 273 from both sides. Okay, and that would tell us that in degrees Celsius, the sample is, let's see, 305, so that'd be 2, so 32 degrees Celsius. Okay, and then you do the exact opposite if you're given a value in degrees Celsius, which is what will happen most often in our gas law problems. So most of the time you'll plug it in for the C, and then you'll add 273. So 12 plus 273 gives us 285. Okay, so that's 285 K. And that's all there is to it. So for gas law equations, remember you want to use Kelvin.